Hi, welcome back to our next video in our series on naming of organic compounds. This series of videos is done in collaboration of teachers in the Eden and Science Karoo Education District. In the first series of videos, the first 4 videos, we looked at how to identify a homologous series. And today we're going to continue with identifying the position of a functional group. As stated in our previous videos, in naming of the organic compound, we start at the back of the compound and figure out the name to the front. In our first 4 videos, we realized that the last part of the name indicates the homologous series, and we figured out exactly how to name that. In this video, we are going to look at this little number over here that indicates the position of the functional group. Sometimes the functional group can be in more than one place in the main chain. Therefore, we need to specify exactly where it can be. There are a couple of homologous series where the functional group does not need to be identified, the position of it, because it can only be in one place. The first example that I want to look at is the alkanes. As you know, the alkanes does not really have a functional group. It all consists of single bonds. So there is no position for the indication of a functional group. Our second example that we have is the aldehydes. If you remember from the previous video, our aldehydes, the functional group of the aldehydes is always a double bond O that is connected to the last carbon of the chain. Since it needs to be on the last carbon, that position cannot really change in any of the aldehydes. It will always be on the last, so I don't have to identify exactly where the functional group is. The example that I've shown you here is pentanol. Another example of a homologous series in which the functional group does not need to be specified is the carbolic acids. Carbolic acids has a double bond O on the last C to which an OH or hydroxyl group is connected. There we see an example of a carboxylic acid with the name pentanoic acid. So the alkanes, aldehydes and carboxylic acids do not need to specify their functional group on exactly where it is. But now let's quickly look at this example that we have here. We have, what is the functional group or the homologous series again? We've got a double bond, so we know this is a alkene. But can you see in this example, the double bond is between the first and the second carbon in the chain. And in this example, I have the double bond in the middle of the chain. So clearly these are not the same compounds. The double bond is not on the same place. In order to distinguish between these two compounds, we need to number the carbons, there they are, in a chain. Now the numbering of the carbons can happen in one of 2 ways. I can start from this side and number 1, 2, 3, 4, or I can start on the other side and then I number 1, 2, 3, 4. And we have a very specific rule to tell us exactly how we will do that. We need to number in such a way that the functional group, which in this case is the double bond, must be as close as possible to the first carbon. Or putting this differently, the functional group must be on the lowest possible, or the carbon with the lowest possible number. If we look at the green numbering, the name of the organic compound will be but1-ene, which says that the functional group is situated on the first carbon. We know where the last part of the name comes from. It's from the alkene. And we're doing this naming from the back, so we've now figured out this part. And this 1 tells us that this functional group is on the first carbon in the chain. If we look at the red numbering and start from this side, our functional group will be on the 4th carbon. That is not the lowest number. So this numbering will not be regarded as correct. The correct name or the correct numbering will be the one where the functional group is on the carbon with the lowest number, which is the green one, and our name for this compound is but one ene. Let's look at this another example. If we look at the blue numbering 1, 2, 3, 4, 5, the blue numbering ensures that the functional group is on the carbon with the lowest number. Alternatively, I could have numbered as it is shown here in yellow, so that number 1 is on this side. If I number from this side, can you see my functional group is connected to the second carbon, if according to the blue numbering. But if I look at the orange or yellow numbering, then this functional group will be connected to the third carbon. Between the two, between this one, which is the second, and that one, which is the third, the blue numbering will ensure that the functional group is on the carbon with the lowest number. So the name of this compound will be but 2-ine. Ine coming from the fact that this triple bond, did I say double bond? I meant triple bond. That this triple bond, which is the functional group of the alkyne, the ine tells us that we are working with a homologous series, the alkynes, and the 2 tells us exactly where that functional group is allocated. Of the 2 possible names that we have, if we use the yellow numbering, our name would be but 3-wine. If we use the blue numbering, it will be but 2-wine. It shows us that the blue numbering indicates the carbon with the lowest position. Okay, let's look at this example of my alcohol. How do I know it's an alcohol? Because there's an OH attached. If I look at the green numbering, 1, 2, 3, 4, 5, my functional group, which is the OH, will be attached to carbon number 5. But according to the blue numbering, my OH group will be attached to carbon number 1. So what do you think will the correct name be? Well, we know it will end in -ol. Why? Because it's an alcohol with the OH group. And now we know before the -ol, there should be a 1, which tells us that this is where exactly the functional group is. The complete name of this compound is pentan 1-ol. At this stage, if I give you a name of an organic compound, then from that you should be able to determine in the first place to which homologous series this compound belongs, and you should also be able to indicate the position of the functional group. But why don't you quickly test yourself and by pasting the following link in your web browser and see if you can complete this quiz. Good luck!